All right, I am now here with one of my oldest friends, Dr. Phil Plait, as well as one of my newest colleagues, Dr. Patricia Craig, and we are going to discuss Venus, a world that I spent most of my life declaring as the place that was simply death, and I may be wrong. Or right, I don't know yet. None of us know yet. I'm going to ask each of you to introduce yourselves, and I'm going to start with you, Patricia.
Sure. Hello. My name is Patricia Craig. I work for the Planetary and Science Institute. My main line of work is Mars mineralogy. I'm a science team member on the MSL Curiosity rover team. I help operate one of the nifty science instruments on the rover called ChemIn, stands for Chemistry and Mineralogy. But back in the olden times, in grad school, I did some research on the mineralogy of the Venusian surface also. That research eventually led to one of my fellow grad students' dissertation. So, we worked very closely on that, got a couple of publications out, but it was very interesting nonetheless. So I'm excited to kind of kind of reinvigorate those thoughts and those ideas and whatnot we have about Venus.
And Phil, you should need no introduction, but you need an introduction.
I think I probably do. I think I'm also way outclassed when it comes to Venus science here, so I'll just make color commentary. Um, but I am used to be a scientist, research scientist. Still think of myself as one. But these days I spend all of my time doing science communication. So I write the Bad Astronomy blog, which has been on Slate magazine, Discover, and now is hosted at Sci-Fi Wire. Do the occasional TV show, wrote and hosted Crash Course Astronomy. And so I basically like talking about astronomy more than doing it these days, I think.
And I want to give a shout out to everyone out in the audience. We just received a $100 donation from Oliver S. And I saw new subs go by. Mistress Fairy gifted 8 subs to the community. And there's another one. Another Oliver. Thank you so much. Um, this 36-hour stream, which we have now completed the first 6 hours of. So that puts us 1/6 of the way through. Uh, this 36-hour stream is here to bring you science, science education, science silliness, and a scale model of the solar system built in Minecraft as one does. And the reason we're doing all of this is to raise money for science. And thank you to all of you who do have that extra right now and are able to give. We know a lot of you can't, and that's fine. It's plague times. Just come join us and laugh about science now and then. So, Venus, once upon a time, long, long ago, was thought of as perhaps a world where there were tropical civilizations lurking beneath the clouds, because it's a fairly Earth sized world that's just orbiting snart closer to the sun. There's a lot of great old fiction out there that has life partying on the surface of Venus. Then Mariner 2 visited. We learned that Venus is a particularly horrific place that eats spacecraft, not like Mars by having them crash, but rather it just dissolves them. Can you tell us just how gross Venus is in its worst?
Well, I think the biggest thing, well, there's two big things. First off, the surface temperature, which is over 500 degrees Fahrenheit. Um, or actually, it might be 500 degrees Celsius. I'm misremembering my units here. But, anyways, super, super hot. Hot enough to melt lead, even on the surface. The other nasty, gross thing about Venus is its sulfuric acid content in the atmosphere. It's not a whole lot, only a few percent, but it's enough that it will corrode metals very quickly, like within a few hours. And if you look back at the Venera missions, the Russian landers that went back there, they only lasted 4 or 5 hours on the surface because of this highly corrosive, highly acidic, um, hot environment.
Venus just is gross. Phil, do you have anything you wish to add?
Well, if I've learned anything from Abbott and Costello movies, it's that Venus is run by women. That was like my first exposure to the sort of the Hollywood version of Venus. Yeah, and the drawings I remember seeing when I was a kid showed it to be swamp like.
Yeah.
I think even when I was a kid, we knew the atmosphere was mostly carbon dioxide, um, and so they thought, well, it must be very warm, and there's warm and there's warm, and Dr. Craig there was talking about a few of the things, and also, I mean, the surface pressure is 90 times the Earth's atmospheric pressure, so that's like going down, I think, 900 meters underwater. So roughly. What is that, about a half a mile, something like that? That's how much pressure is on the surface. So it's just an awful, awful place. And I don't know if it's the last place I would have expected to find, evidence of life in the solar system, but I think it would have been the last place with an atmosphere I would have expected to find life in the solar system, or evidence of life in the solar system. Thus,
Yeah.
teeing this up for you, Pamela.
Yeah. So Patricia, what were your thoughts on the possibility of life prior to this year?
There's been some speculation over time. Are you talking to me or
Or
Patricia?
either of you take this?
I'll jump in right away. I guess there's been some speculation, even going back 30, 40 years or more, that there could be airborne life on Venus because while it's extremely hot at the surface, higher up in the atmosphere, it's actually much cooler. And there's at 50 kilometers up, 60, the temperature drops to be relatively Earth-like. And as a matter of fact, that's right around where the atmospheric pressure is kind of like sea level here as well. I don't think there's any free oxygen, but that didn't stop Earth 4 billion years ago from developing life. And it was life itself that created the oxygen that we breathe now. So it's not ridiculous to think there could be life in the atmosphere of Venus. The problem is, that's pure speculation. Is there any evidence of it?
Yeah, Patricia?
Yeah, I agree. Venus would have been very low on my list of places to look for evidence of life. But as so many other planets have surprised us in the past, once we start exploring, we find all kinds of things that we never expected. Um, but yeah, there the in my opinion, the likelihood of there being life on the surface is relatively low. However, we do see here on Earth a lot of what we call extremophiles or extreme life forms that can survive, not just survive, but thrive in these extreme environments. Places in high temperatures or high pressures or high acid content. So it's not really entirely out of the question that life may have persisted on Venus at some point in time, either on the surface or in the atmosphere, where like Philip said, was a lot cooler. We kind of imagine these little tiny particles in the air that are host to these little microcosms of microbes just floating around in the atmosphere doing their thing.
And I don't know about Phil, but I remember when I first saw Empire Strikes Back with the Cloud City. My thought was Jupiter, Saturn, Venus, and Venus's atmosphere, while probably not able to support a city in the clouds, could readily support a balloon-borne civilization if they were lifting like their own environmental canisters in the process. But the idea of microbes being lofted that way was it was something that took the likes of Carl Sagan to come up with many decades ago. And part of what limited me in thinking that it might have life is I couldn't figure out how life would get into that kind of a living in the clouds. Like how does that evolve? My own imagination was clearly limited. But one of the more recent discoveries was that Venus might have had water in the not too distant future. Is that something you can talk about at all, Patricia?
Well, it depends on what you mean by not so distant. If you're
Well,
talking,
900
yeah,
million years.
right. In geologic terms, not so distant.
Yeah.
Um, but yeah, we see these features on Venus that look like long, thin, meandering streams. And because we haven't um, explored Venus with the kind of robotic spacecraft that we've been able to, like for Mars or for Titan or even Europa, getting close, high res images of the surface, um, it's hard to tell if these features were formed by a liquid water or a liquid, maybe other sort of solution that makes it stable on the surface, or if this was a very highly fluid lava that also has other implications for Venus. That maybe it's still more volcanically active than what we thought. And so that kind of leads into the next question of you pose the question, how could these microbes have gotten into the atmosphere? My first thought would be volcanoes, volcanic eruptions. We see even here on Earth these what we call the black smokers, where we have this hot magma coming up, this hot water and gases coming up through the surface. We have them at the bottom of our oceans. We also have things, like geysers and whatnot on the surface. But a lot of these areas play host to life, both macro and micro scale. So, yeah, it's an interesting thought to think, could some of these microbes have evolved in the subsurface and then through some large volcanic eruption got blasted into the atmosphere, and now they're just kind of hanging out, at these high level clouds on Venus.
And one of the things that really gets me about how these discoveries are being made is it's not necessarily because we're getting better data. There is a Japanese mission there right now. Our ground-based telescopes are getting better at observing the atmosphere of Venus, but a lot of this understanding, the changes in how we understand the volcanism, the changes in how we formulate our atmospheric models, are due to computational changes that have revolutionized how we look at, for instance, the Magellan data that was taken back in the 90s. And Phil, you and I were babies in our career when that data started coming back. Do you remember the Magellan data and all of our collective disappointment when it came in?
I thought it was cool.
Well,
I mean, it was disappointing in that it's like, well, the surface of Venus doesn't look anything like Earth in that, we're not seeing evidence of continents. We're not seeing, you look at Mars and you can see there's a lot of cratering. There's as Patricia said, there's lots of evidence of flowing what looks like water, and it's pretty clear now that it was. We see a lot of the minerals that water deposits on the surface of Mars. And you don't see a lot of that on Venus. It just looks like something. Well, it looks like hell because it is, right? And clearly, this is a surface that has been modified extensively by volcanism over and over again. And when you look at it, it's hard. It's not impossible, but it's hard to find impact craters. Now, Venus has a super thick atmosphere. It's hard for asteroids to get through unless they're really big. They just break up in the atmosphere before they hit the surface. But even then, you expect to find some. And it just looks like basically over time, these volcanoes have erupted and repaved the entire planet. In fact, that reminds me something you said earlier, Pamela. I never really thought about this. They've talked about exploring Venus by balloon. You let a balloon there that is apparently impervious to sulfuric acid, let it float over the surface and take pictures and everything. And it occurred to me when you said, you can't have a cloud city in Venus. And I realized, wait, you can, right? If the density of the atmosphere is denser than water at the surface, then you could float a battleship in the atmosphere of Venus. And I have to think about this a little more carefully. But if you basically enclosed it, you could make a balloon out. You could make a Led Zeppelin and have it fly around Venus. I don't know if that's true, but I'll have to think about that.
That buoyancy pressure, people.
Buoyancy,
And
yeah.
I
Right.
thank you, Poltergeisty, for donating all of the subs to folks in chat. Everyone, get out your emotes. To those of you watching on Now Media Radio, what you are seeing is the messages that stream across screen when people donate to this program. If you want to see your name stream across the stream, go to hangout.cosmoquest.org, click the donate link, give only what you're able to give, and your name will scroll across the screen. And we'll squeal a little bit because you're making science happen and helping me pay my part time staff, all of whom are offered medical benefits. Because it's plague times, people. It's plague times. This is what we do.
Good on you.
So, going back to Venus and buoyancy, um, yeah, if the density of the clouds is greater than that of water, you could float a battleship. And now this is bringing back bad 1980s anime that I deeply regret going back and rewatching as an adult. Um, of
Oh,
Phil just had the same memory.
yeah, and sorry to interrupt. I also looked up the density of the air, and at the surface, it's only 6% of liquid water.
Oh, so you can't quite do it.
That's disappointing.
That is disappointing. Um, but the pressure, that's deeply confusing. So what you have is a small number of particles moving very, very quickly to create the high pressure with not a lot of stuff. And balancing out the density and the pressure and the buoyancy equation, I can't do that in my head. So I'm going to choose to
Really?
maintain hope that we could float battleships in the atmosphere of Venus. Um, so we've had these amazing advancements in the computer models we use to understand Venus that has changed from being one massive volcanic uplift, which is what we used to think, to now thinking maybe there's even ongoing volcanism. Patricia, can you bring us up to date? Because I feel like everything we know about Venus has changed in the past 3 years. Can you bring us up to date about what our current thinking is about the surface of Venus?
Well, the the idea that the surface is very young is still maintained. That hasn't changed. But you're right. There are some things about the surface that we didn't know 5 or 10 years ago. Um, the for example, like you mentioned, the volcanic activity. We're seeing new images or new features, or what we think are new features, being formed. Now, this could be um, a resolution issue between Magellan data and what we have now. But it could also be actual evidence. It could be, true that there are volcanic uplifts, such as what we call corona. They look like, big pancakes kind of lifting up out of the surface. Um, and even volcanic deposits. We think we see actual, flows, new flows that weren't there before. Um, like you said, we're also learning a lot about the atmosphere, and how, not just about the surface and the atmosphere, but about how the two interact. Because obviously, when you have that high pressure, that high temperature, you're going to get some sort of reaction. The example I like to give is in the lab. We try to simulate a geologic process. Well, we don't have hundreds of thousands of years to recreate this process, so we increase the temperature and we increase the pressure, and that speeds up the process. Well, Venus is doing that for us, and it's kind of interesting to think that there's all kinds of chemical and mineralogical interactions going on between the surface and the atmosphere, that we can't really, that we don't see anywhere else in the solar system. And so, especially with the highlands, you get, if you look at the radar data, which is what we have on a global scale
And
of
pause to
Venus.
explain what the highlands are for a minute.
Right. Okay. Sorry. What I mean by highlands, I mean high altitude areas, mountaintops kind of thing. Because Venus has mountains and it has low lying areas, just like we see on Mars or on Earth. When I say the highlands, I mean above about, I think, well, if I remember correctly, about 4.5 to 5 kilometers altitude. In the radar data, we see these highlands are radar bright. In other words, they are reflecting more of the radar signal that we send to the surface than the lower lying areas. And it's pretty continuous across the entire planet. So some early theories were that this is sort of like a frost, right? Like a snow line, like we have snow here on Earth, and that's made of water condensing out of the atmosphere onto the surface as ice. Well, obviously there's not a lot of water on Venus, so what else could condense out of the atmosphere? Lead. Bismuth, galena, all these heavy metal sulfides, or sulfur containing minerals, that are in fact bright in a radar sense. And so there's been a significant uptick in research of not just, like you mentioned, the modeling of the atmosphere because of our increased computational abilities, but also looking at how that atmosphere is interacting with the surface.
And
And I apologize for any background noise. My neighbor's mowing his yard going by my window here, so if it
Sign of
gets
the
too
times.
loud, I'll mute myself.
it's all good. This is the year we see everyone's pets, children, and hear all of the gardeners. And that's okay. Now, the big reason Venus is on our mind today is we're building it in Minecraft. But the big reason Venus has been on many people's minds recently is the detection, we think maybe, maybe not, in the atmosphere of Venus of the element phosphine, or molecule phosphine, rather. It's not an element, it's a molecule. And Phil, were you one of the lucky few who got the embargoed release?
No, actually, I heard about it through a friend. Somebody said, "This is so exciting about Venus." Sends me a direct message through Twitter, and I'm like, "Wait, what? What about Venus?" And I wound up contacting one of the scientists and getting the preprint and all the information and reading about it and thinking, "Huh, this is interesting." So yeah, I mean that made a huge splash. This idea that there's this molecule called phosphine, and it's like ammonia. Ammonia is nitrogen and three hydrogen atoms stuck to it, and phosphine is phosphorus and three hydrogens stuck to it. And it's on Earth. It's deadly. It's
Yeah.
used as a poison. In my area,
Deadly to
people.
life like us.
Yeah, yeah, yeah. If you breathe it in, yeah, see ya. Nice knowing you. It's used in my area actually to poison rodents and vermin that get into fields and things like that. So it's pretty nasty stuff. And it's created on Earth either artificially as a poison or by anaerobic bacteria, the kind of things that you get in a rotten corpse and things like that. So it's pretty nasty. To find that in the atmosphere of Venus is really interesting. And the authors, I mean, there were sort of two steps to this. One is, did we see the signature of this stuff? And they go through all that and say, we think so. And the second step is, well, what can make this? And the idea is, they looked at volcanism, they looked at lightning, they looked at meteors going through the atmosphere, they looked at all these different chemical processes that can generate phosphine. And they said, some of these can do it, but not at the levels we see. We're seeing a lot of it. And so that was, interesting. Could this be from life? And made a big splash. And I was super careful writing about it. Like, we may have seen evidence of life in the atmosphere of Venus. And a lot of people online were like, Venusians. Um,
It's so weird for us as science communicators because we've spent so much of our career saying it's not life, it's never life, it's not aliens, it's never aliens until it is, but that's not probably going to happen. We say it so much. And in the lead up to this, I like you didn't get the embargoed release, but then had things leaked to me because lovely humans wanted to make sure I knew. And I was putting out all of we're going to be doing live coverage of this release. We're going to be doing coverage of this during the daily space, not saying what any of the stuff was. And one of the folks in our team, Binary Ablaze, Annie Wilson, she made the comment, "It's aliens, isn't it?" And I just sat there and I didn't know what to do. And I let my silence speak for me. Yeah, yeah, it's
there, I
yeah.
even created a meme for this, so there you go. Yeah.
So what was it like for you, Phil, having it might actually be life while doing psychom?
Well, we've been through this before with the Mars meteorite and some other meteorites that have come from Mars that look like they had life in them.
Yeah.
And it turns out, probably not. And that happens quite often. And with
Yeah.
this one, reading the paper, watching their press conference, I thought that they were sufficiently skeptical. That even in
Yes.
one of their slides, it says, "We're not claiming this is life. What we're saying is that we think we've seen phosphine. We don't know where it comes from." So I actually thought that they handled themselves pretty well through all this. Whereas, you and I can both name astronomers who make outrageous claims, and then they're like, "Who, moi?" When the media go nuts. And in this case, it was like, no, I think they did this right. And as the more I read about it, it was like, well, I have some issues with the research, but there were no dead ends. I'm not saying that like, well, this has made me just poo-poo it.
Yeah.
One problem I had is that what they were doing is that they were looking at a spectrum of the atmosphere of Venus. So you take
Mhm.
the light coming from Venus, you break it up into a bazillion individual colors, and there are molecules in the atmosphere that will absorb very specific colors. That's basically what astrophysics is based on, the fact
Yeah.
that we can look for these fingerprints of different atoms and molecules in distant objects because they do absorb these very specific colors. So you see, you just see the light and you're measuring the colors. All of a sudden, there's this big dip, and that big dip is going to be from a specific molecule. And they found a dip where phosphine should be. And the thing is, no molecule, no atom has just one color it absorbs. They usually absorb a bunch of them, and they only saw this one. And so even then I said, well, it would be nice if they, could find a different color to look at where phosphine should absorb and see if they see it. But let's assume right now that what they saw is real, and go from there. And it turns out there have been quite a few papers coming out in the past couple of weeks saying, well, maybe not so much. Have you been looking into this too, Patricia? Have you been keeping up with all this? You know more
Um,
about Venus than I
probably,
do.
yeah, probably not as much as I should have, but I did get that impression from their press conference that they were very skeptical, even themselves. They were like, they almost challenged other scientists to come in and say, prove us wrong. This is our data, take it for what it's worth or what you think it's worth. And I admired that so much because, like you said, so many times people will make what they think is such an amazing discovery and they're like, this is what we found, and then it's like, well, wait a minute, hang on. I often think about the detection of methane in the Martian atmosphere. When that paper came out, that was a huge thing. And again, it was using spectra, just like what you described, Phil, that we see this little blip in the light curve, and that blip occurs right where methane is supposed to be. Now, methane, as you might, a lot of people think of cow farts when you think of methane, right? It's produced, most of the methane on Earth is produced by biologic processes, but it can also be produced through geologic processes, no life involved. Um, and so, whenever we talk about the possibility of life on Mars, especially methane producing microbes, which we have tons of here on Earth, everyone always cites that paper. But there always has to be a little caveat that, yes, it is possible that this stuff is formed through non-biologic processes. And I think they did a really good job of putting all of that out front, saying, this is what we have, this is what we think it could be, but these are all the other possibilities that it could be as well.
And one of the things that kind of breaks my brain with this research and the methane research is we have spent a lot of money and human hours and graduate degrees and senior scientist research into trying to come up with ideas about what molecules existing and what combinations in atmospheres are indicative of biological life. What are the biosignatures of life? And phosphine is one of the molecules that, as far as we know, doesn't have a geological explanation on a world like Venus. Universe, as I've said many times and will say many more times, likes to surprise us with its creativity. Human beings rarely are as imaginative as actual science in what it comes up with. And so I have to ask, do you think it is possible for scientists to look at a world in our own solar system or in an alien solar system and see biosignatures, but not be able to go out and grab something to either see bite back or at least see move around in a slide to say that it's life? Can we believe that there's life based just off biosignatures?
I think short answer to that, in my opinion, is no.
I
I'm a
agree.
firm believer that we will say, yes, that is life when we see something scurrying across our camera. Or, like you said, come, and bite the rover or something. It is incredibly difficult to unambiguously prove the existence of life. Um, I've heard the term, what is it? Hold on, let me get it right. Um, the absence of evidence is not evidence of absence, and that's true when it comes to looking for life on other planets. But you could also take it to the extreme that, oh, we have no evidence of a flying spaghetti monster on Earth, but does that mean that it could still exist? Um, I think what we have to do is gather as much data as possible and rule out as many other scenarios as possible. And if a biologic process or if life is the only remaining possibility, then there's our answer. But until we're able to definitively do that, there's always going to be that skeptic, that possibility, that doubt in our mind that, well, maybe it isn't life because what we're seeing could be done without life.
Right, and what you said too, the flip side absence of evidence is that you can have evidence, but it's
Mm-hmm.
evidence. It's not proof, right? So
Right.
Right.
you can find evidence of something. I could take a picture of something in the sky and say this is evidence of a flying saucer, and that's different than saying this is proof.
Right.
And it could be correct. You could have actual evidence, like some observation of Venus that is ironclad. We have found this molecule, and everybody goes, "Yeah, you did." But is that proof of life? The answer is no, right? Then, like you said, you have to go there and see something. And the other problem, the other half of that is your evidence good? And what we're finding right now, what's the papers that have come out in the past couple of weeks are showing that the original evidence for the paper may not be right. That they observed Venus with a telescope, and the data weren't that great. So they said, you know, we're going to go to this other telescope, which is a lot better.
Hmm.
And when they did that, the evidence was strengthened, and that's good. That's a step in the right direction.
Mhm.
But now what people are showing is that the way the data were processed, you have to actually do some things to the data to make it analyzable. The example I like to give is when you take a picture with a camera, if the camera is way more sensitive to red than green, all your pictures look red. And it's like not everything around you is red. That's just the camera influencing the picture. So you have to manipulate the numbers a little bit. You try to understand how the camera works and remove its influence. And so the astronomers did that. And what it looks like is that when they process their data that way, they may have amplified the signal where they see that dip. It may have made the dip look real when it may not be. And some other astronomers have observed other lines of phosphine and have not seen them. And again, that doesn't mean the original observations are wrong, but these are steps in casting doubt on the conclusion. And so I wouldn't say, no, it's all wrong, throw it in the wastebasket. But I would say, yeah, we have to be a lot, we should have been skeptical in the first place, and I think most people have been. But this makes it even more, so I think that they could certainly still be right, but it's not looking like it right now.
And
Along those same lines, it almost it begs the question: did they actually detect phosphine in the first place, or are
Mm-hmm.
they detecting transient phosphine? Is it being created and then later destroyed so that it's not being seen by people who come by later, to make other observations? Again, going back to Mars, the methane in the atmosphere is seasonal. It doesn't hang out in the atmosphere for very long. And so if you're not observing at the right time, you're not going to see it. But you're right. It is sadly the evidence, or I guess the lack of evidence now is kind of stacking against this original claim.
but all we can do is keep using facts to build the story.
That's right.
And every improvement in observing technology, every improvement in computational technology allows us to understand what's going on a little bit better. And I have to share a comment that Falco Online made in the twitch.tv/CosmoQuestX chat. Falco writes, some scientists on Betelgeuse are watching Sol 3 and thinking, methane and phosphine, what's going on there? Let's wait for other papers.
That
Yes.
better be a planet on a really big orbit.
That's true. That is true. And if you are out there watching us on Now Media Radio, you can ask us questions and make comments using the hashtag #hat2020. We are coming up. We have 10 more minutes left in this segment before we go to Mines on the 49s and see how things are going in our scale model of the solar system in Minecraft, where everything is built to the scale of Jupiter is 256 blocks across. And it turns out that when you use this scale, you can fit our solar system out to the minor planet, the dwarf planet, the Kuiper Belt object. Call it whatever you want. I don't care. Eris, our solar system ends at Eris, and we will be talking about what is and is not a planet in an hour and 20 minutes when we're joined by Mark Sykes, Charles Detrlick, and Phil Metzger. During the next hour, we'll be joined by Skylius, and we're going to be talking about Space Engine and ways you can, well, explore your solar system from your desktop without having to build everything in Minecraft. Because while that's fun, it takes a community to do it. Now, science is a collaborative and a competitive. It's not supposed to be a sport, but let's face it, sometimes it sure feels like one. Right now, one of the competitions that's going on is to figure out how to get back to Venus. Uh, the US hasn't had a spacecraft there, I think, in my lifetime. What what plans for going and getting more data are on the horizon? Either of you take this.
Well, I know that the startup company Rocket Lab is talking about sending a probe there. Um, and I've not been able to find a lot of information. Apparently, a couple of the two guys that started up this company are really, really interested in Venus. They had this idea of sending a probe to Venus anyway. Now they're talking about it more, but finding hard engineering information like, okay, you're going to send a probe to Venus. What's its mass? How much scientific data are you going to, or instrumentation you're going to put on it? And I haven't been able to find any information about that. So this may still be notional, or I may just be really terrible at finding this information. I haven't called anybody or anything yet. I haven't gotten around to doing that.
So the only place that I've seen that information is I actually heard it during one of the press conferences,
Mm-hmm.
and it was mentioned that they're looking at, I believe, 13 kilograms of cargo, which is nothing. This is a
Yikes.
suitcase sat basically that they're sending. The Electron rockets that Rocket Lab makes, I like to think of as huggable rockets. They have a 6 foot diameter, kind of like a redwood tree, but flies into outer space. And the Rocket Lab company is working with the team out of MIT to try and figure out what is possible instrumentation wise, and has tweeted that they're doing this. We just don't have, I don't think anyone has any details right now. Unfortunately, though, there aren't any currently funded missions in the works where there's actual hardware being put together on a bench. So
I
it may be
forget.
a while yet.
Yeah, I forget. I think it was maybe 4 or 5 years ago now, when the next, they call them flagship missions, which are like, the big new, going to do all kinds of new science never done before type missions. A call for those were put out, and two of the final five were missions to Venus, and not sadly neither of them got chosen, because NASA can usually only afford one per proposal cycle. Um, and so, yeah, it's kind of like, well, NASA, what do you think now? Kind of thing. But I mean, not to take anything away from, I think it was the Dragonfly mission that was eventually chosen to go to Titan, which is Saturn's moon.
Yeah.
But yeah, I feel like this has kind of, reinvigorated at least the interest from the public into going to Venus, and hopefully that will carry over into the next flagship mission. I would really hope that the people who proposed those two missions weren't overly discouraged, and it's like, look, we got the public on our side. Let's try these missions again.
It could go the other way too. If this phosphine detection goes away,
That's true.
the public may then say, well, why are we bothering going to Venus then? It's
Yeah.
like,
That's very
because
true.
it's an awesome planet and we should learn a lot more about it. So I always, public opinion can be a little fickle. NASA can certainly be fickle because they, of course, have to, their flag blows in the direction of the public winds. So, it's hard to say what's going to happen here. And I'm hoping that this can be settled relatively soon. I mean, the obvious thing to do here is say, ALMA, which is the array in Chile that observed this the second observatory they used to observe Venus. It's like, give them more time. Here's a week. We're just gonna look at Venus for a long, long time, get really solid data, and see what happens. Try some other things first before we spend $100 million to make a detector just to look for phosphine on Venus. We should still go to Venus, still look at the atmosphere. Looking at these wavelengths is a good idea anyway. So all of this is all fine. We can still look for phosphine when we get there, but I think there's a lot of work to be done first too.
And an interesting question is being brought up by Falco Online. Would it make more sense to try and colonize Venus than Mars? If terraforming is on your list.
Well, they both suck.
And that
Honestly.
is a perfectly reasonable answer. We have 3 more minutes before we go to mines on the 49s. And I'd like each of you to have a chance to say what you're looking forward to doing next and plug any places where people should go to follow what you're up to. Patricia, I'm going to go to you first. What's up next?
So do you mean in terms of Venus or just in general?
in general.
Okay, in general. Well, so I am actually trying to revamp some old Venus data that I gathered through experiments as a grad student. I'm hoping to put that together as a proposal and submit it in the coming months. But still, like I said, my main job is with the Curiosity rover. We just recently drilled again. I think it was our 29th drill hole on Mars. So, milestone, yay. So we'll be busy over the next few weeks analyzing that and getting that, in the context of all the other drill samples we've taken. And then eventually we're headed up to the what we call the sulfate unit, which is an area on Mars where we see a lot of sulfur bearing compounds. Was a lot of minerals laid down in a water rich environment, but different than the water than we see elsewhere on Mars. So it's really exciting in the next few months what Curiosity is going to be doing.
That sounds amazing. Um, Phil, what are you up to next?
Well, I want to say first that that all sounds really cool, and I love the fact that you're taking old data and trying to reprocess it and do stuff with
Yeah.
it. I always love hearing that we save everything now,
Yeah.
so it's really cool that you can take old stuff and look at it again.
Well,
Um,
sorry, not to interrupt again, but what I'm hoping to do is run some more experiments on Venus, either borrow a chamber or build my own chamber to run experiments at temperature and pressure, which is, as we've talked about before, the 90 bars, the 450 Celsius. You're basically building a bomb, which is really cool.
wow,
And we're gonna run experiments in this bomb.
yeah, you heard it here
As one
first,
does.
FBI. Um, as for me, I'm not doing any research, but I'm still writing. I'm working on a bunch of different things. We just filmed How the Universe Works the next season, so keep your eyes open for that. I love being on that show, and sci-fi.com/bad astronomy. That's where you can find me writing every day, and I suspect I'll have an article up on Venus, possibly on Monday. If not then Tuesday for sure, talking about all the stuff that we've been talking about here.
Cool.
And it's always great to get to, I mean, it feels like a Girl Scout song, old friends, new friends, all together talking about Venus. And thank you so much for being here. We are now going to switch on over to Minds on the 49s, this time with Ms. Brick Kitten. Thank you both for being here.
Thank you for
Thank
having
you.
us.
And Ms. Brick Kitten, the screen is yours, and everything looks fabulous.
Thank you very much. Everything can hear me all right. Awesome. You could also see me. Hi. Been playing with OBS, getting my settings right. And so here we go. We are outside once again, the welcome center to this wonderful build. Not a lot is going on out here. I think everyone's going grabbing dinner or lunch or something because it kind of got a little quiet for a little bit. However, work does still progress. So on the overworld out here, it still looks pretty much the same. We'll be following this. We have many hours to go, so don't worry, we will see lots of things. We have some fresh bushes with some, these are note blocks that are set up to look like planters. All right, I am going to jump right into space. And as we go into the center of the sun. Now, earlier today, I don't remember which person said it, but they were wondering how far out. So if we look at the center of the sun, this is just the core, the deep dark core where helium is getting, or hydrogen is getting smashed into helium at a temperature of millions of degrees. And then we walk out. I've made these small little portals at the cardinal points of the sun. And when we travel out, we can see the sun keeps going and going and going and going. That's just the core. You can see it behind me as I go further and further away from it. You will see it disappear. And if I keep going out, yes, this is why I have put in tons and tons of buttons to teleport us around, is because space is big. I can't express how big space is. We think we know how big things are. We do not know how big things are. So this is the edge of the sun. This is the edge of the main sphere of the sun. The corona would extend for about another 2,000, 3,000, 2,000 blocks away from here. And the corona is the wispy section of the sun where we are still trying to figure out, why is the corona so hot? The corona is hotter than the surface of the sun, but it is so wispy that it's hard to measure. All right, so I am going to go ahead and put back to the center because it's faster. There we are, back here. Let's check Mercury. Let's go to Mercury very quick. Mercury looks still about the same place it was last time. Get some builders in here. Let's get these going. It's looking beautiful. It's got a great start to it. We want to get these planets going and get them done. So next we'll go on to Venus. Venus, I think we're all working on the splashy, flashy, big, huge planets at this point. Again, Venus is still in about the state as it was last hour. Go ahead and sign up on the forum. I will add you to the allowed list and we can get you into the server. You can get working on these, help us make this into a reality. So we're going to go back to the sun once again. And on Venus, Earth, still a ghost sphere. The moon is good though. We have a pretty good moon. So we'll fly out to the moon real fast. And here's our moon. The moon is good. We have the Israeli satellite that took a nosedive into the moon earlier. It was almost successful, but just didn't quite make it. Hello. Go ahead. Okay, thank you. All right, so we're going to go right back to the center core of the sun. And from the core of the sun, we can now go to Mars. Mars has been done very well. It looks amazing. Pixel Riffs and a few other of the people here has joined us. We have the colonized. The potatoes look like they have grown very well, so we'll have food on Mars for a little while. Got one little smoldering volcano here in the form of a campfire, because it's about the scale we have. And we have the beautiful, dirty snow caps that if we land there, we could probably melt them for fuel for our rockets. It's an amazing thing. All right, now back to this the sign disappeared. Return to, I can't spell, so return to center of sun. Welcome, center. All right. Sometimes in creative, you accidentally destroy a block, didn't even realize you destroyed it. Let's go bouncing back. All right. I have not put in the staging platform for the asteroid belt yet. Those are very small objects. Once I get out there, they will be very quick builds. However, Jupiter, let's go to Jupiter. Last hour, we watched Jupiter being built by our resident guest Minecraft expert Pixel Riffs. And it looks like the clouds of Jupiter are coming along amazing. Are we actually in space? Sparkle asks if we are actually in space. And kind of, yeah. This dimension that we are building Minecraft in would be the end dimension. And if you are an avid Minecraft player, everyone knows you go to the end so you can float around floating islands, kill the Ender Dragon, get shulker boxes and chorus fruit and endstone. Ah, there's Pixel Riffs. I just saw some blocks pop in. And there's our man Pixel Riffs. He's just cooking along. This is looking amazing, Pixel. Keep going, sir. All right. And we'll need to set up the Galilean moons. The Galilean moons are very important, and I believe we'll be doing a couple of the smaller moons as well, but definitely need to get there on the Galilean. Oh, Hex is up here too. Hexacorsacoron, there he is. He's up top, so he's starting some of the higher latitude cloud banding. And again, this is looking amazing, guys. Keep going. All right, so our next stop shall be Saturn into station, into solar system. So let's pop back to the sun. Let's go to Saturn. When we pop into Saturn, our two main people who are working on the rings of this beautiful gas giant planet, they've taken a break for dinner and lunch and just recuperate, get some food into them, get a little rest. I don't have any plans for satellite beyond a ring of terracotta. I need smart people to tell me what to do. And we just had Annie join the game as well. But as we can see, we're starting to fill out cloud layers on the thing. But most important, if you know anything about Saturn, you know that at the top it is hiding a secret. And that secret is the hexagon at the North Pole. So I am working here to get the hexagon going. It's going to be a fun little challenge to get the hexagon in, vary the block palette to give it a better texture. These are just, from my point of view, this is just a base layer of blocks. I will swap different block styles in here, like carpet and so forth, in order to give it a nice, beautiful texture like we see going on at Jupiter. Let's see here. All right, let's scroll back to the Welcome Center. Actually, we can do it faster because I can teleport. All right, so if I teleport on, we can go to Neptune and Uranus. Uranus. One of those pronunciations will work. We'll know what you're talking about. And we still have a ghost sphere here. This will be a big, beautiful ball of blue when we get some people out here to start working on it. It'll be gorgeous. So again, come join us. Back to the sun. One more time out to Neptune. And Neptune as well is just a giant ghost sphere at the moment. Looking forward to more participants coming in and helping us fill these planets out. And then I believe Pluto has been completed by Keeper of Maps. Let's go see what his work came out to be. And there we go. And of course, what would Pluto be without that adorable little heart looking at us from across what would that beautiful little heart be without looking at us from across the edges of the solar system? It's gorgeous. We should probably put a penguin on there too or something. Anyhow, that is our current progress on the huge, ginormous solar system build we have going on right now. Please come in and join us. I'm sure someone is putting in the chat right now the command to sign up. I've been reviewing the survey form submissions as the day goes on and have been trying to quickly add people as possible. So you can come in and join us and have fun. Thank you very much, everybody. So I personally am going to continue working on the North Pole of Saturn, get that hexagon all fleshed out and make it look like something that people call the portal to another dimension. or if you're a scientist, you call it a standing wave function. So